everybody. This is the Deephaven community team with another Friday demo. This is November week 5. First off, I'm going to show some of the improvements I've had with our Typescript conversion for grid. So I've been converting a whole bunch of the grid code to TypeScript, adding all the types for everything. So this will make it a lot easier to use, and with autocomplete having all the types, it'll just make it a lot easier to use, and adding docs as well. So if you can see the diff, it's adding a lot of information to the code and cleaning it up. Already it's found a couple of bugs, so it's helping clean up the code. That's it from me. I think next up we have Christian with the big decimal changes.
Hello, everybody. So as some of you may have been hearing, for my current task, which is to make a particular demo work with Deephaven, I had a need to make a decimal format as a type for Avro in particular for the demo to work. And one thing that was not working in the web UI in particular was to show a big decimal-based Java type table in the UI. The barrage support for it was not there. So I added that, and I also, for my own needs from the point of view of testing, I added Parquet support for reading and writing it. So I'm going to show just how that looks like in the UI. To find the right window here. And so the first thing that I'm going to do here is just use PyArrow to generate some data, okay? So this is going to be some pretty simple Python code. I need pandas. I'm going to create a very humble and small pandas data frame with some values. So this is my data frame, just one column plus the index. The column sees values in floating points, okay? So this is like regular, Python type float, which is actually a double underneath from the point of view of Java and C tradition. So we can see that by doing this. I'm going to print the type of the first row. So you see it says NumPy float 64 there. So what I'm going to do now is I'm going to create a second column on the same data frame of decimal type. So Python has support for this decimal type, which is essentially this floating point with decimal representation, fixed floating point format. So I created here a second column called values decimal, and if we show it, it looks very similar from the point of view of what is printed out, but if we look at the type of that thing that we just added, let's do the same command that we did before, but let's use the other column. We can see that it says decimal.decimal. It's a class, the Python class for it. So, okay, that's it. And now I'm just going to write that in a Parquet file. So now I have a file in this directory. It's called decimaldemo.parquet. And I need to run Deephaven and try to load that file. Okay, so let's do the import, and then I can say t equals Parquet tools read table decimal demo.parquet. Oh, sorry. I need to say the right directory. Okay. So, yay, we have decimal, big decimal type in that value of the decimal column. And we can do the opposite, write table t data decimal demo out of Parquet. Okay, cool. We just wrote it. Now let's take a look at those two files from the point of view of the actual Parquet format that is there. So I can say I can use this command line tool from the Parquet CLI to essentially show the schema. So the file that we loaded, the file that we manually generated first in Python, essentially has this schema. We have the two columns, one of them is decimal. And if you look here, we actually are reading something that is fixed bytes, essentially 4 bytes always, fixed size. And when we look at the one that we write from Deephaven, it's going to look a little bit different because we actually use a variable size binary, which is essentially a binary string of bytes, but not a fixed size. And that's a kind of like important distinction from the point of view of getting decimal data in Deephaven and getting decimal data out of Deephaven. When we read decimal data, all of these external tools, Parquet, Avro, in general, what they understand decimal to be is this type that includes a particular fixed precision and scale. So we can see here, this is a decimal 97, which means 9 digits of precision in total. 7 of them are to the left of the decimal point, right? In what we actually get in Deephaven, we have an arbitrary precision big decimal that can have any precision. It essentially grows as much as it needs from the point of view of memory storage, depending on the number of digits that what we're trying to store has there. So when we read something, of course, there is a maximum, but we can generate other tables. And in general, any table that we generate, a table that is taken, you cannot know in advance what is going to have, because it's dependent on what operations you're going to be doing with them, right? So what we do when we write out, and this is an important thing to know, in particular with Parquet, is that we look at all the values in the column and find the right precision and scale so that we don't lose any data, and then we write that. That's why we move from a fixed number of bytes to a variable binary type of field. So yeah, that's it. That's my demo.
All right. Cool. Thanks, Christian. All right. Next up, we have Corey showing us some CSV reading improvements.
Hi. I'm going to attach my VM display. This might work and it might not. So let's see if I can share my screen. Let's see. Share a tab. Okay, so the purpose of this project was to speed up CSV reading.
Sorry, Corey, can you make the font a bit bigger, please?
Oh, yeah, how do I do that?
Perfect. Thank you.
Oops. Was that overkill? Yep. And the basic idea here is, we were using a couple of open source libraries like the Apache CSV Reader and so on. And they're just not optimized for reading data at scale. They use Java, there's a lot of inefficiencies, there's garbage collection, this and that. And so just by trying to write the code as tightly as possible and being really economical with data structure reuse and so on, we've gotten some pretty good numbers. So without further ado, I have one table, my integrals. This is a table of 10 million integer numbers. There's about 5 columns, and this is reading it the old way. So we can start our stopwatch.
May I hum the Jeopardy theme song?
And
okay, I just died actually, like waiting for that.
It's supposed to be done. I made this shorter. I made it within our attention spans, but I guess I exaggerated our attention spans. All right, so 36 seconds for that file. And there you can see there's 10 million rows that kind of look like this format you're seeing in the bottom. And, go to the bottom, and there it is. So now I will do read CSV extended and also give it the async flag, which also means that it overlays column reading and file parsing together to the extent that it can pipeline. And the same data, oh, don't fail me now. All done. So 3 seconds. So it's about a factor of 10. You know, I could do, I don't know if I should do another file with floating point numbers. It's going to turn out to be kind of the same. And it's especially attractive. We have a really especially slow datetime parser in our library. And so by kind of redoing that and hand tuning that, we're getting kind of fast datetime parsing too. I think that's probably enough for a demo, unless you want to see the other files below.
No. I
Okay.
think we get the idea. It's 10
Cool.
times faster. That's awesome.
Yeah.
All right. Very good,
I
Corey.
wish it were 20.
Always striving for the best. All right. Next up, we have Devin showing aggregations.
Hey. So you might have seen me, I don't remember if it was a week ago or 2 weeks ago, doing some demonstrations on input tables. Recently, I've been reworking how the engine and the table API represents some aggregations, specifically when you want to do an aggregation on all the remaining columns. And I'm just going to have a short demo about that. Share a window. Is everybody able to see this now?
Yep. Looks good.
Great.
Yeah.
So we've got an input table here. I'm just calling base. It's 1,000 rows. And essentially, it's just a bunch of random data. So we've got keys 0 through 999. Then we've got a random group between 0 and 10. Then we've got a random byte. Then we've got a random short, random int, random, what is this, long, then random float, and random double. In each cycle, so I've got a little program. In each cycle of the program, it'll have a 1% chance of changing any of these rows. And we'll see it ticking here in a second. So based on the program parameters right now, there are 3 groups. And there are a bunch of different ags that have been created. And again, this is in a different way than we would have created them before. It's going through a new interface. And this is just a part of my testing for it. I made sure that all of them were selected through here. So if you go to the min by, this is based on the group key. Here's the minimum. And you can see these look like they're probably the minimums. If you look at a group by, that's going to be the result of the group by. Here's the median. But anyways, what we can do is we can turn this program back on and change some parameters a little bit just so we can see it ticking. I'm going to change it from 3 groups to 10 groups, and hopefully you'll see stuff ticking here. So we immediately jumped up to 10 groups, but we still got 1,000 input keys. So you'll see this distribution is reordering right here, and then all of our ags are ticking. Our min's probably going to tick a little bit less because the minimum's less likely to change. But here we've got just all the different aggregations created via the new API, and then being triggered via input tables. So that's the demo.
All right. Thank you, Devin. All right. That's all we've got for this week. We'll see you next week. Bye.
We're gonna